Let's look at the decay products of the W boson. First, electric charge. We started with a total electric charge of +1 on the W boson. Now we have a neutrino and anti-electron. The electric charge on the neutrino, of course, is 0, and on the anti-electron is +1. Now, on the WIMP candidate, we have a total electric charge of 0, and on the Z boson, we have a total electric charge of 0. Let's look at spin. We started with a total spin on the W boson of -1. And now on the neutrino, we have a -1/2. And on the anti-electron, we have a +1/2. We have 0 spin on the WIMP candidate, and we have a -1 spin on the boson 0. Since the spin on the neutrino and anti-electron cancel 1, the total spin will be -1, which is the same amount of spin that we had on the W boson plus. Let's look at weak charge. The total weak charge on the boson plus was 1/2. Now we have a weak charge on the left-handed neutrino of +1/2, which is what is indicated by the standard model. And on the anti-electron, we also have a spin of +1/2, also indicated by the standard model. Now, if we look at the contribution of the WIMP, we have 0 contribution to the spin. But on the Z boson, we have a contribution of, not to the spin, but to the weak charge of -1. And so the -1/2 spin here will negate the +1/2 spin here. It's not spin, but weak charge, and given a total weak charge of +1/2, which is what we had on the W boson also. Now, let's look at isotopic spin. The isotopic spin on the neutrino is +1/2. And the isotopic spin on the anti-electron is also +1/2, given a total isotopic spin of +1. But the isotopic spin on the WIMP candidate will be -1/2, which gives us a total now of +1/2, and the isotopic spin on the boson 0, Z particle, is indicated to be 0. So we still have the same isotopic spin that was on the W boson, which was +1/2. flavor. We'll see that of course, neutrino and anti-electron have no flavor, and the WIMP candidate is taking away a flavor charge of 1. And the Z boson has no flavor. And we started with a flavor of 1 on the W boson. And to conclude, we look at the color charge. And because these are leptons, we see that the contribution to the color charge by each component, in the case of the neutrino, we have the anti-colors of purple, orange, and green summing to white or 0 color charge. And for the anti-electron, we have yellow, blue, and red also summing to 0. And of course the boson 0. WIMP candidate has a color charge of 0, as well as the Z boson has a color charge of 0, which is what the color charge was on the, of course, W boson. So that concludes our review of the quantum for the T-quark and its decay products, and we see they are consistent with the standard model.